There exists a moment in scientific inquiry where the data and the theory diverge so dramatically that the divergence itself becomes the story. Not the fossil record, not the geological surveys, not the carbon isotope ratios locked in ancient sediment. The story is the silence that follows when someone asks a question that makes the entire field go quiet. That silence is what I want to discuss with you because it reveals something about how we process information that contradicts our foundational assumptions about who we are and when we arrived. Let me begin with something that happened almost 8 years ago, though you may not have heard about it. Two researchers, one from a prestigious institute studying atmospheric systems, the other from a university's physics department, looked at a problem that had been sitting unresolved in the literature for decades. They asked themselves a question that no major institution had formally posed before. If a technological society comparable to our own had existed on Earth millions of years ago, would we possess the methodological tools to detect it in the geological record? Not could we, but would we? There is a difference between capability and likelihood that matters more than most people realize. These scientists did not claim that such a civilization existed. They made no assertions about the past. What they did was run a systematic analysis. They modeled which materials decay, which degrade, which persist through the incomprehensibly long stretches of geological time. They considered concrete, steel, plastic, ceramics, everything we consider permanent or near permanent in human terms. Their conclusion was stark and uncomfortable. None of it survives. Not meaningfully. Not in a form that would be identifiable as artificial rather than natural. Buildings last decades before structural failure. Centuries at most with favorable conditions. Within thousands of years, geological forces have recycled everything into an unrecognizable state. Erosion, chemical weathering, pressure, heat, the constant remorseless process of plate tectonics grinding everything that stands above the surface back into the planetary substrate. What survives 50 million years, what persists through that kind of temporal distance, is chemistry. Isotope ratios, trace element concentrations, a chemical fingerprint locked into rock with a permanence that no human archive can match. The implications of this analysis were never challenged. No published rebuttals appeared. No major research institutions funded investigations to test it. Instead, something closer to an institutional shrug occurred. The paper was published, cited a few times, and largely left alone. That abandonment is more revealing than any direct refutation could have been, because it suggests that the scientific community understood exactly what the paper implied and calculated that engaging with the implications carried more professional risk than leaving the question dormant. Now consider what sits in the geological record approximately 56 million years before the present day. At that point in Earth's history, the planet had already been habitable for complex multicellular organisms for nearly 600 million years. Life was diverse, abundant, and well-established across every ocean and continent. Then something happened. Between 3 and 7 trillion tons of carbon entered the atmosphere over a geological blink of an eye, perhaps a few thousand years at most. We know this from the sediment record. We have drilled cores from every major ocean basin. We have measured the isotopic composition of that carbon with extraordinary precision. The carbon carries a specific signature. It is enriched in the lighter isotope. This is not ambiguous. This is not disputed. 30 years of research, thousands of published papers, the most thoroughly studied rapid carbon event in Earth's history, all confirm this single fact. The carbon that flooded the atmosphere at this moment was biological in origin, not volcanic. Not from the planetary interior, from something that was once alive. Something that was burned or decomposed and released at a rate that overwhelmed the planet's natural carbon cycling mechanisms. What happened next was equally dramatic. Global temperatures rose by 5 to 8 degrees. The deep ocean acidified. A third of all species living on the ocean floor vanished from the fossil record. Life did not disappear, but it was devastated in ways that took the planet 200,000 years to recover from. 200,000 years. Longer than modern humans have existed as a species. Longer than our entire evolutionary history to this point. The Earth took longer to heal from this event than the entire span of Homo sapiens. The names of things matter in science because they affect how we think about them. This event is called the Paleocene-Eocene Thermal Maximum. The acronym is PETM. It sits in the geological record dated with precision, studied with intensity, described in tens of thousands of research papers. The basic facts are not controversial. They are among the most documented phenomena in paleoclimatology. But when you add up every known natural mechanism that could have produced this much carbon, volcanic outgassing, methane hydrate destabilization, thermal decomposition of organic-rich sediments, something does not balance. The volume of isotopically light carbon in the record exceeds what the combined natural sources can account for. This gap has been noted in the literature for decades. It is not hidden, it is not controversial, it is recognized and carefully discussed and never quite closed. 3 independent lines of evidence: the carbon isotope analysis, the temperature record, the biological response, all point to a rapid release of biological carbon at a scale that no purely natural mechanism available in the models can fully explain. And then, in 2018, a paper appeared that reframed the entire discussion, not by introducing new data or new theory, but by applying a simple logical framework to the question of what we would see if the impossible had occurred. If a previous civilization had existed and disappeared, what signature would persist in the geological record? The authors approached this with complete scientific rigor. No speculation. No mythology. Just physics and chemistry and the documented behavior of materials across deep time. The conclusion was uncomfortable. A vanished civilization would leave behind no cities, no roads, no structures, no artifacts. All of that would be recycled by the planet within timescales that are negligible on geological scales. What would remain would be chemistry, isotope ratios, elemental concentrations, a carbon signal with a specific fingerprint recorded in the minerals that form from ocean sediment. That signal would be preserved indefinitely. A future geologist examining that layer would note the anomalies. They would see the gap in the explanation. They would study it extensively. And if they had no framework for interpreting the data, they would place it in the literature as an open question. Now, read that conclusion again and then look at the PM. A carbon event with a biological fingerprint. A volume that exceeds known natural sources. A rate of release comparable to industrial output. An open gap in the explanation that 3 decades of research has not closed. Sitting in rock that is 56 million years old. 2 independent lines of peer-reviewed science. One describing what we would not be able to tell if a civilization had vanished. The other describing an event whose characteristics perfectly match what we would expect to find. The connection has existed in plain sight for almost a decade. The mainstream scientific establishment has barely acknowledged it. Something left that fingerprint in the rock 56 million years ago. We know what the fingerprint looks like. We do not know what made it. And we now possess a formal scientific framework demonstrating that we may never be able to know with certainty either way. That is not the conclusion. That is the beginning. Let me ask you to do something. Take a moment and imagine every structure humanity has ever built, every city on every continent, every bridge, every road, every dam, every power plant, every satellite, every plastic bottle, every discarded device, everything we have constructed across 300,000 years of human existence, and especially the last 2 centuries of industrial civilization. Imagine all of it stacked together, all of it preserved intact, all of it sitting here in perfect condition. Now close your eyes and imagine leaving it alone, walking away, letting physics do what physics does. Come back in 50 million years and look at what remains. The specific details matter because the details explain why the absence of evidence is not the same as evidence of absence. Consider the structures first. A modern city built from steel and reinforced concrete begins deteriorating the moment maintenance stops. Within decades, water infiltration cracks the concrete, rust develops in the steel framework. The structural integrity fails within centuries. The building collapses under its own weight. Within a few thousand years, the rubble is buried under sediment and overgrown by vegetation and weathered by every atmospheric process that operates at the surface. Within tens of thousands of years, the steel has oxidized completely. The concrete has chemically decomposed. What remains is a lens of chemically unusual soil enriched in certain elements, but with no geometry, no structure, no indication that something was deliberately constructed. It looks like a natural deposit. It gets cataloged as a natural deposit. A city the size of New York becomes a thin smear of anomalous chemistry in a single compressed layer of sediment. Now consider the materials we consider the most permanent. Plastics. We produce over 400 million tons annually. We worry about plastic pollution as if it will mark the Earth forever. It will not. Ultraviolet radiation breaks the polymer chains. Microbial activity accelerates the degradation. Within a few 100,000 years, the plastics are gone, chemically absorbed into the sediment, leaving behind trace concentrations of unusual carbon compounds that a geochemist with the right instruments might detect, but would never identify as packaging or bottles or shopping bags. They would be cataloged as organic carbon anomalies and nothing more. Metals fare slightly better in persistence, though not in identification. Copper, lead, zinc, rare earth elements concentrated by mining and industrial processing. These can persist in sediment for millions of years as anomalous concentrations. But without context, without any surviving structure or artifact, they look like natural mineral deposits. The Earth naturally concentrates metals through volcanic activity and hydrothermal processes. A future geologist would need an extremely specific reason to suspect that an enrichment of rare earth elements in a 50-million-year-old sediment layer came from a factory rather than a volcano. No such reason would emerge from chemistry alone. Nuclear material is the longest-lasting identifiable trace. Some radioactive isotopes produced by nuclear reactors have half-lives in the millions of years. After 50 million years, even the longest-lived products would have decayed to levels extremely difficult to distinguish from natural background radiation. A few anomalous isotope ratios at specific locations might survive, but interpreting them as evidence of technological activity rather than natural nuclear reactions would require a framework that no geologist would have reason to apply. So what actually survives 50 million years in unambiguously readable form? One thing, the carbon signal. The isotopic composition of carbon locked into carbonate rock and ocean sediment. Light carbon enriched in the carbon-12 isotope deposited globally and rapidly in volumes that correspond to massive combustion of ancient organic material. That signal is durable. That signal is global. That signal is locked into the chemistry of the ocean floor by the organisms that build their shells from dissolved carbon in seawater. When those organisms die and their shells accumulate on the seabed, the isotopic signature is preserved in the resulting limestone. 50 million years later, a researcher drilling into that limestone and running samples through a mass spectrometer will find the signal exactly where it was deposited, exactly as strong as it was when recorded. This is the message that geological time cannot erase. Here is the part that should make you sit with this for an extended moment. We are producing that signal right now. 150 years of industrial activity, primarily the combustion of coal, oil, and natural gas, has released roughly 500 billion tons of isotopically light carbon into the atmosphere. That carbon is being absorbed by the oceans. It is being incorporated into the shells of marine organisms. It is being deposited on the seabed in sediment that will eventually become rock. The isotopic signature of our industrial civilization is being written into the geological record at this moment. In 50 million years, it will be there, a thin layer of light carbon, anomalous, rapid, biological in origin, with a volume that future researchers may or may not be able to fully account for using the natural mechanisms in their models. We are creating our own PETM. We are writing the same entry into the same record with instruments precise enough to watch ourselves do it in real time. What happened after this framework was published? Almost nothing. The paper appeared in a peer-reviewed journal. Mainstream science publications covered it. The public briefly took notice. Then the field moved on. No follow-up studies, no funded research programs, no teams formed to rigorously test the hypothesis against the specific anomalies of the PETM or any other geological event. Years of silence from the institutions best positioned to pursue the investigation. That silence is worth examining closely because it reveals something about how scientific communities actually function versus how we believe they function. When A credentialed researcher publishes a novel hypothesis in a peer-reviewed journal. The normal process is clear. The community responds. Other scientists test it. They try to confirm or break it. They run their own models. They look for predictions the hypothesis makes and check whether those predictions match reality. That adversarial process is how science corrects itself. It is how good ideas survive and bad ideas are discarded. The absence of that process is not neutral. It tells you something. But what it tells you is not that the hypothesis is wrong. If it were obviously wrong, it would have been professionally rewarding to write a rebuttal demonstrating the flaws. No such rebuttal has been published. What the silence tells you is that the question is professionally dangerous. The incentive structure of academic science is asymmetrical. If you pursue this line of inquiry and find evidence supporting it, the discovery would be extraordinary, but the professional risk would be enormous. If you are wrong, your credibility is permanently damaged. You become the scientist who chased an impossible idea in the geological record. No amount of methodological rigor protects you from that characterization once it takes hold. If you stay quiet, nothing happens to you. You continue publishing within the accepted framework. You continue receiving funding. You continue advancing. The cost of asking the question is borne entirely by the person who asks it. The cost of not asking it is distributed invisibly across the entire field. Nobody is punished for leaving the gap open. Only the person who tries to close it takes a risk. This creates a blind spot that is structural, not conspiratorial. No one decided to suppress the hypothesis. No committee met in a dark room and agreed to bury it. What happened is simpler and more human. Everyone individually calculated the professional cost and benefit of engaging with it. Everyone individually concluded that the cost was too high and the benefit too uncertain. The result is collective silence that looks like consensus, but is actually the absence of investigation. The question was not rejected, it was abandoned. There is a difference between a question tested and found wanting and a question never tested because no one was willing to be the first. Now consider a number that puts this abandonment into perspective. Earth has been habitable for complex multicellular life for roughly 600 million years. The Cambrian explosion occurred approximately 540 million years ago. Since then, the planet has supported an unbroken chain of increasingly complex biological diversity. Modern humans have existed for roughly 300,000 years. Our industrial civilization has existed for approximately 200 years. That means our entire industrial presence on this planet represents roughly 130 millionth of the window during which complex life has existed. Now ask the question that no mainstream institution has formally calculated. What is the probability that in 600 million years of complex biology on a planet chemically favorable to life, with oceans rich in organic chemistry, with an atmosphere capable of supporting metabolisms of extraordinary diversity, we are the first and only species to develop the capacity to alter the planet's atmosphere at an industrial scale? Not the first to build radio telescopes, not the first to develop written language, the first to burn stored organic carbon at a rate sufficient to leave a detectable isotopic signal in the geological record. That is a much lower bar than intelligence. It requires only the biological capacity to extract and combust stored energy at scale. And in 600 million years, across millions of species, through mass extinction events that repeatedly cleared the ecological slate and opened new evolutionary pathways, we are expected to believe it happened exactly once. The honest answer is that we do not know. We cannot prove that something was here before us. We also cannot prove that it was not. Those two positions are not symmetric. One is comfortable. One requires rethinking our place in the history of this planet. We have collectively chosen the comfortable one. We have done so not because the evidence supports it, but because the absence of evidence in a record that we now know cannot preserve the relevant evidence has been treated as though it settles the question. It does not. The record is not clean. The record is blind. What we cannot see is not the same as what does not exist. Now let me take you forward in time, but not forward to our future. Forward to an epoch that ended roughly 12,000 years before the present day. An epoch called the Younger Dryas, named after a small Arctic flower that reappeared in pollen records when the world suddenly grew cold. Before this boundary, the planet was warming. The last ice age was releasing its grip. Glaciers that had covered much of North America and northern Europe were retreating. Sea levels were rising. Forests were reclaiming land locked under ice for tens of thousands of years. Megafauna roamed a continent, becoming increasingly hospitable. And then everything reversed. Temperatures plummeted, the warming stopped, glaciers advanced, ecosystems that had been recovering collapsed. The largest animals on 4 continents vanished from the fossil record. An entire human culture disappeared so completely that archaeologists spent decades not knowing what happened to them. The event was fast. It lasted roughly 1,200 years. It was fast in and fast out. And the question of what caused it has been fought over in academic journals for 40 years, with intensity suggesting the answer matters to more than just paleoclimatologists. The standard explanation is elegant and supported by significant evidence. A massive pulse of fresh water released from a glacial lake in North America flooded into the North Atlantic and disrupted the ocean circulation system that carries warm water from the tropics to the high latitudes. This great conveyor belt of ocean currents effectively shut down. Without the warm current, temperatures in the northern hemisphere dropped rapidly. The cooling lasted until the freshwater pulse dissipated and circulation restarted. The physics is sound. The mechanism is real. For decades, it was considered sufficient. Then the physical evidence started arriving. In 2007, a team of researchers from multiple institutions published findings that did not fit the meltwater model at all. Across North America, in a sediment layer dated precisely to the boundary, they found nanodiamonds. Tiny crystals of carbon, some only billionths of a meter across, that form exclusively under conditions of extreme pressure and temperature. You cannot make nanodiamonds with a volcanic eruption. You cannot make them with a flood. You cannot make them with a climate shift or any geological process operating at surface pressures and temperatures. There's a very short list of natural mechanisms that produce nanodiamonds at this concentration and distribution. That list has one entry, a high-velocity extraterrestrial impact. The force of an asteroid or comet fragment striking the Earth at tens of kilometers per second generates pressures and temperatures sufficient to convert carbon into its diamond crystal structure instantaneously. The resulting nanodiamonds are ejected into the atmosphere and distributed across a wide area. The initial discovery was dramatic. What followed was more dramatic. Over the next 15 years, nanodiamonds from the same time horizon were found at additional sites, then more sites. By 2020, the evidence had been replicated at over 50 separate locations across 4 continents: North America, Europe, Asia, and the Middle East, all in the same stratigraphic layer, all dated to the same narrow window around 12,800 years before the present, not approximately. The same layer, the kind of synchronicity that in geology means one event, not several. Along with the nanodiamonds, researchers found other markers: magnetic microspherules, tiny spheres of iron and other metals that form when rock or soil melts rapidly at extreme temperatures and then solidifies in midair. These are a well-established signature of impact events. They were found in the same layer at concentrations far above natural background. Iridium, a metal rare on Earth's surface but relatively abundant in asteroids and comets. Iridium enrichment in a global sediment layer is the signature that Luis and Walter Alvarez used in 1980 to identify the asteroid impact that killed the dinosaurs. Iridium enrichment was found in the Younger Dryas boundary layer, not at the same concentrations as the dinosaur-killing impact, which was a far larger event, but at levels significantly above background. Shocked quartz. Grains of mineral quartz deformed by pressures far exceeding anything produced by terrestrial geological processes. Shocked quartz forms only under the kind of instantaneous extreme pressure generated by a hypervelocity impact. It was found at Younger Dryas sites, and there was charcoal, massive concentrations distributed across multiple continents indicating widespread simultaneous fires. Continental scale burning events that left their signature in sediment across thousands of kilometers. Every one of these markers individually is consistent with a cosmic impact. Taken together, they form a pattern that has only one known cause. Something hit the Earth 12,800 years ago and hit hard enough to distribute ejected material across 4 continents simultaneously. Then in 2018, the same year the Silurian hypothesis was published, a completely independent team announced a discovery that gave the impact hypothesis something it had been missing: a crater. Using airborne ice-penetrating radar, scientists identified a structure beneath the Hiawatha Glacier in northwestern Greenland. A circular depression 31 kilometers across, buried under 900 meters of ice. The structure had all the morphological features of an impact crater. A raised rim, a central peak, the characteristic geometry produced when a massive object strikes a surface at cosmic velocity. Initial analyses suggested the impact occurred roughly 12,800 years ago. Think about what that means physically. A rock or comet fragment large enough to excavate a hole 31 kilometers wide struck the northern ice sheet at the precise moment the world was ending. The energy released would have been staggering. Billions of tons of ice vaporized instantaneously. Superheated steam and pulverized rock ejected into the upper atmosphere, a shock wave propagating outward at hypersonic speed. The thermal pulse would have ignited fires across hundreds or thousands of kilometers. Material lofted into the atmosphere would have been distributed globally within days, carried by stratospheric winds, and deposited in a thin layer across every continent. Exactly the layer researchers found with exactly the markers they documented. The dating of the Hiawatha crater has since been debated. Some analyses propose an older formation date, potentially placing the impact tens of thousands of years earlier than the Younger Dryas boundary. This debate is legitimate and ongoing. But here is what the debate does not change. The crater exists. An impact of that scale in that region was physically possible. The evidence layer from 12,800 years ago contains exactly the markers such an impact would produce and distribute globally. Even if the Hiawatha crater itself predates the Younger Dryas, the impact evidence at the boundary layer remains. The nanodiamonds are real, the microspherules are real, the iridium is real, the charcoal is real. They do not need a specific crater to validate them. They need an impact. Now consider what was living on the surface of North America when this happened. The Clovis people, named for distinctive stone spear points discovered near Clovis, New Mexico in the 1920s and 30s. They were the first clearly identifiable widespread human culture in the Americas. Their tool technology, a specific method of shaping stone into thin fluted projectile points of extraordinary precision, has been found at archaeological sites from coast to coast, from southern Canada to Central America. They were not a marginal population clinging to survival at the edge of habitable territory. They were a successful, well-adapted culture that had spread across an entire continent over thousands of years. They hunted mammoths and mastodons. They had sophisticated tool-making traditions. They thrived in an environment that, by the standards of Ice Age North America, was abundant and productive. And then they vanished. Within one human generation, the distinctive Clovis tool technology disappears from the archaeological record entirely. Not a gradual decline. Not a slow transition to a different tool style. Not a migration pattern that can be traced to a new region. One stratigraphic layer, they are there. The next layer, they are not. The standard explanation is overkill. Human hunters drove the megafauna to extinction. The food web collapsed. The culture that depended on those animals could not sustain itself. That explanation is coherent on paper and has one critical problem. Overkill is gradual. It takes generations. It leaves a trail of declining animal populations, shifting hunting strategies, evidence of dietary adaptation. The Clovis disappearance does not show any of those signatures. It aligns within the resolution of available dating methods with the impact evidence layer. One boundary, one moment. Everything changes at once. This is the element that transforms the Younger Dryas from a regional climate story into a global catastrophe. In the same narrow window around 12,800 years ago, the megafauna of North America went extinct. Mammoths, mastodons, horses, camels, giant ground sloths, short-faced bears, direwolves, saber-toothed cats, an entire ecosystem of large-bodied animals that had survived multiple previous climate shifts over hundreds of thousands of years. Gone. Simultaneously, woolly mammoth populations across Eurasia declined sharply. Large fauna in South America experienced parallel extinctions in the same window. The same pattern repeating across ecosystems that had no contact with each other, no shared human population, no mechanism for transmitting hunting pressure from one hemisphere to another. Hunting pressure is inherently local. A human population in what is now Arizona driving mastodons toward extinction cannot simultaneously affect woolly mammoth herds in what is now Siberia. These populations were separated by an ocean and thousands of kilometers of ice. Whatever reached them all at roughly the same moment was not a hunting strategy. It was not a gradual climate shift. It was something that did not care which continent it was affecting. Synchronized global extinction requires a synchronized global cause. The meltwater hypothesis provides a regional cooling mechanism for the Northern Hemisphere. Regional cooling does not explain 4 continents losing their largest animals in the same geological instant. An impact event does. An impact large enough to distribute ejecta globally, ignite continental-scale fires, and collapse food webs through destruction of vegetation and disruption of atmospheric chemistry does. The evidence is in the layer. The nanodiamonds are in the layer. The fires are in the layer. The extinctions are in the layer. And the institutional consensus still treats the meltwater hypothesis as the primary explanation and the impact evidence as a fringe alternative. Here is why that matters beyond academic debate. The meltwater hypothesis has been dominant since the 1980s. Decades of papers have been built on top of it. Careers have been constructed around it. Funding has been allocated to research programs that assume it. When impact evidence began appearing in the early 2000s, it did not enter a neutral scientific environment. It entered a field where the existing explanation had institutional momentum, where the researchers most qualified to evaluate the new evidence were also the researchers whose professional identity was built on the old explanation. This is not a conspiracy. It is a structural problem. It is the same structural problem that explains the silence around the Silurian hypothesis, the same incentive asymmetry, the same professional cost calculation. If you challenge the consensus and you are right, you rewrite a chapter of Earth's history. If you challenge the consensus and you are wrong, your career suffers damage no subsequent paper can repair. If you do not challenge the consensus, nothing happens to you at all. The result is that the explanation which accounts for less of the physical evidence maintains its dominance, not because the evidence supports it more strongly, but because the institutional cost of replacing it is higher than the institutional cost of leaving the gap open. Something hit this planet 12,800 years ago. It burned continents. It killed species that had survived every previous ice age cycle for hundreds of thousands of years. It erased a human culture from the archaeological record in a single generation. And the evidence for it has been sitting in a sediment layer across 4 continents, waiting for someone to connect the dots. Now I want to take you to a place and a time where someone did connect the dots, not with scientific instruments, with stone. On a limestone ridge in what is now southeastern Turkey, roughly 11,500 years before the current era, somebody began building the most sophisticated structure on Earth. 6,000 years before Stonehenge, 7,000 years before the Egyptian pyramids. In an era when, according to every standard model of prehistoric development, no human population on the planet should have been capable of organized monumental construction. The site is called Göbekli Tepe. Here is what the standard timeline says about the people who built it. They were hunter-gatherers, they had no agriculture, they had no permanent settlements, they had no writing, they had no administrative structure, no state, no organized labor system. By every conventional measure of civilizational development, they were not supposed to be able to do what they did, and yet the physical evidence proves that they did it. The site consists of at least 20 circular enclosures, each containing multiple T-shaped limestone pillars. The largest pillars stand over 5 meters tall and weigh up to 10 tons. They were quarried from bedrock approximately 500 meters from their final positions, transported without wheels, without draft animals, without any of the mechanical advantages that later civilizations would develop, and raised into position with precision that modern structural engineers find impressive. The pillars are not blank, they are carved. Animals rendered in high relief cover their surfaces: foxes, serpents, scorpions, vultures, wild boar, cranes. The carvings are not crude, they are detailed, proportional, executed with sophistication that implies a mature artistic tradition stretching back generations before construction of the site itself. The total excavated area covers roughly 90,000 square meters. Ground-penetrating radar surveys indicate that what has been excavated represents less than 5% of the total complex. The vast majority of Göbekli Tepe remains underground, unexcavated, waiting. The logistical requirements for this construction are staggering when placed against the assumed capabilities of the builders. Quarrying and shaping 10-ton limestone pillars requires sustained effort by skilled workers. Transporting those pillars 500 meters across uneven terrain without wheeled vehicles requires coordinated teams of dozens of people working in organized shifts. Raising the pillars into vertical positions and placing them with geometric precision within carefully planned circular enclosures requires engineering knowledge, planning, and a command structure capable of directing complex multi-stage projects over extended periods. And every one of these workers needed to be fed. Hunter-gatherer societies by definition acquire food through foraging and hunting. These activities require mobility. They require the population to follow the food. They do not naturally produce the caloric surplus necessary to support a large stationary workforce engaged in non-subsistence labor for months or years at a time. And yet the site exists. The pillars are there, the carvings are there, the engineering is real. The archaeologist who excavated Göbekli Tepe for 2 decades proposed a resolution to this contradiction that turned the standard model of civilizational development on its head. He argued that the construction itself drove the invention of agriculture. The workforce needed food. Feeding the workforce required cultivating grain. The temple came first. Agriculture followed. If this was correct, and no one has successfully refuted the argument, then everything we thought we knew about the sequence of human development is backward. We assumed agriculture came first, that surplus food production enabled permanent settlements, that permanent settlements enabled social organization, and that social organization eventually produced the capacity for monumental construction. The evidence says the opposite happened. Something motivated people to build before any of those preconditions existed. Something so urgent, so important, that it justified the invention of agriculture itself as a necessary support system for the construction effort. What was that something? What was so important that it preceded and caused the development of farming? The answer may be carved on Pillar 43. Called the Vulture Stone, it is one of the most heavily decorated pillars at the site. Its surface carries a complex arrangement of animal figures: a vulture with one wing raised, a scorpion positioned below it, a headless human figure, a disc above the vulture that could represent the sun. Other animals arranged around the central figures in positions that seem deliberate, purposeful, encoded with information that the carvers expected someone to understand. For decades, the imagery was interpreted as mythological: a hunting scene, a religious narrative, a depiction of ritual. Generic categories assigned to carvings whose meaning had not been deciphered because no one had applied the right analytical framework. In 2017, researchers published a study that changed the interpretation entirely. They treated the animal figures not as mythological symbols, but as representations of star constellations. Using astronomical software capable of modeling the positions of stars as seen from any location on Earth at any date in the past, they mapped the animal figures against the actual night sky and searched for a date when the configuration matched. The match they found was precise. The arrangement of figures on Pillar 43 corresponds to the positions of constellations as they appeared in the sky approximately 10,950 years before the current era. That date falls at the onset of the Younger Dryas, the beginning of the catastrophe, the moment the world ended. The researchers concluded that Pillar 43 is not a mythological scene. It is an astronomical record, a date stamp. the most important date in the history of the people who carved it, encoded in a format that does not depend on language, does not depend on cultural context, does not degrade over time. The positions of stars change slowly and predictably due to the precession of Earth's rotational axis, a cycle that completes roughly every 26,000 years. Any civilization with basic astronomical knowledge and the mathematical tools to calculate precession can read the date encoded on Pillar 43. The message was not written for the people who carved it. They already knew what happened. The message was written for whoever came after them, for us. They encoded the date of the catastrophe in the only universal language available to them, the geometry of the sky itself, and preserved it in the only medium that survives geological and civilizational collapse. Stone. That is not decoration. That is not mythology. That is an act of communication aimed across thousands of years at an audience the builders knew they would never meet, calculated to survive every possible scenario except the destruction of the stone itself. And then they buried it. This is the detail that most accounts mention without fully absorbing its implications. The site was not abandoned. It was not gradually covered by natural sediment accumulation over millennia. The people who built it, or their immediate descendants, deliberately and systematically filled the enclosures with rubble, soil, and debris. They sealed the entire complex under meters of compacted fill. They covered what they had spent generations constructing. Why do you bury something you spent that much effort building? There is only one answer that makes sense of the effort involved. You bury it to protect it. You bury it because you have seen what happens to things on the surface when the sky falls. You bury it because a structure above ground is vulnerable to fire, to blast waves, to the environmental chaos that follows a catastrophic event. A structure under 3 meters of compacted fill survives almost anything. Impact debris, continental fires, centuries of climate chaos, the complete collapse of whatever civilization comes next. They were not building for themselves. They were building for whoever came after them. The entire site is a message sealed in stone and buried underground, designed to survive the next catastrophe and be found by whoever was still alive to dig it up. We found it. We are still arguing about what it means, but the astronomical encoding on Pillar 43 has been published, peer-reviewed, and replicated. The date is there. The message is there. The question is whether we are willing to hear what it says. Now travel 1,500 kilometers south to the Giza Plateau in Egypt, where another stone structure sits with its face pointed due east toward the rising sun. The Great Sphinx, a lion-bodied monument carved from the living bedrock of the plateau, the largest monolithic sculpture on Earth. The Orthodox dating places its construction at approximately 2,500 years before the current era, during the reign of Pharaoh Khafre of the 4th dynasty. That dating is based on historical records and stylistic association with other known structures from the same period. It is not based on any direct physical measurement of the Sphinx itself. In 1990, a geologist with a doctorate from an Ivy League university examined the limestone walls of the enclosure surrounding the Sphinx. What he found was a pattern of erosion that did not match the expected age of the structure. The walls displayed deep vertical weathering channels, the specific pattern produced by prolonged exposure to heavy rainfall running down a vertical stone surface over centuries, not wind erosion, which produces horizontal scouring, not sand abrasion, which produces a different surface texture entirely. Rain, sustained heavy repeated rainfall over an extended period. Egypt has not experienced that kind of rainfall since before 5,000 years before the current era. The last period of sustained heavy precipitation in the region ended roughly 7,000 years ago, when the climate shifted and the Sahara transitioned from a green, fertile landscape to the desert it is today. If the erosion on the Sphinx enclosure was caused by rainfall, the structure must have been exposed to that rainfall, which means it must have existed before the rainfall ended, which means it was carved before 5,000 years before the current era, a minimum of 2,500 years older than the Orthodox dating and potentially far older than that. Now add the astronomical alignment. The Sphinx faces due east, On the spring equinox, the constellation rising on the eastern horizon changes over time due to the precession of Earth's axis. At 2,500 years before the current era, the official date of the Sphinx, the constellation rising on the eastern horizon at the spring equinox was Taurus, the bull. The Sphinx is not a bull. At 10,500 years before the current era, the constellation rising on the spring equinox was Leo, the lion. The Sphinx is a lion. At that date, it would have been staring directly at its own celestial counterpart rising above the horizon. Two independent lines of evidence, one geological, one astronomical. Both point away from the orthodox dating and toward a much older origin. They do not converge on exactly the same date, but they both indicate a period thousands of years before the historical record of dynastic Egypt begins. And if the Sphinx is that old, where is the civilization that built it? Where are their other structures, their tools, their settlements? The answer is the same answer that researchers gave us when they analyzed what would survive 50 million years of geological processing. Gone. Erased by 7,000 or more years of geological processing, climate change, and sea level rise. Any coastal settlements from that era are now sitting under tens of meters of water in the Mediterranean and the Red Sea. The absence of corroborating evidence is not evidence against the geological argument. It is exactly what the geological argument predicts. Now consider what the body of the Sphinx tells you about its own history. The proportions are wrong. The body is massive, extending over 73 meters in length. The head is visibly, obviously disproportionately small relative to the body. This disproportion is not subtle. It is apparent to anyone who looks at the structure without prior assumptions. The most widely accepted explanation, endorsed by many mainstream Egyptologists, is that the head was recarved. The original head, whatever it depicted, weathered badly over an extended period of exposure. When the pharaohs encountered the structure, the original head was significantly eroded. They recarved it into the image of a pharaoh, reducing its size in the process because they were working with a diminished volume of weathered stone. If the head was recarved, the original is gone. Whatever the Sphinx originally depicted is lost, but the body remains. The enclosure walls remain. The geological weathering remains. The astronomical alignment remains. Someone before the historical record of Egypt begins carved a lion-bodied structure from the bedrock of the Giza Plateau and oriented it with precision toward the point on the horizon where Leo rose at the spring equinox. Whoever they were, they possessed astronomical knowledge sophisticated enough to encode a specific celestial alignment into the orientation of a massive stone monument. And they left no name, no text, no inscription that we have found connecting them to the structure. 700 kilometers to the north, in the region called Cappadocia in central Turkey, the evidence of ancient catastrophic knowledge takes a different form entirely. Not monuments above the ground, but cities beneath it. Derinkuyu is the largest currently known underground settlement in the region. It extends 18 levels below the surface. It was designed to house approximately 20,000 people. It has ventilation shafts reaching from over 60 meters underground to the surface, independent wells accessing the water table, stables for livestock, storage rooms capable of holding years of food supplies, rolling stone doors weighing hundreds of kilograms that could seal individual tunnel sections from the inside, creating airtight barriers between levels. A complete self-contained environment capable of sustaining a large population with zero contact with the surface for an extended period. There are over 200 similar underground settlements in the Cappadocia region. Some are connected by tunnels extending for kilometers. The official explanation attributes them to defense against historical invaders. That explanation works for 3 levels, maybe 5. It does not work for 18. No army in the historical record of that region ever pursued defenders 18 levels underground. The logistics are impossible. The darkness alone would stop them. 3 to 5 levels provides complete protection against any human military threat. What justifies the remaining 13 levels? Distance from the surface. More rock between you and whatever is happening above. Independent air supply capable of filtering contaminated atmosphere. Multi-year food storage. Complete surface independence. You build this when the threat is not soldiers. You build this when the surface itself becomes uninhabitable. when the air is poisoned by ash or chemical fallout, when the sun is blocked for months or years, when the temperature has dropped so far that agriculture is impossible, when everything that sustained life above ground has collapsed and will not recover for years. These are not the threats that appear in the historical record of Cappadocia. These are the threats that appear in the geological record of 12,800 years ago. 3 sites, 3 different responses to the same knowledge. The knowledge that the world had ended once violently from above and that it could end again. The memory of that catastrophe spread across every inhabited continent, compressed into the oldest stories humanity possesses. Stories that 500 independent cultures tell in nearly identical terms. Over 500 cultures on every inhabited continent on Earth tell a story about a flood. Not a flood. The flood. A cataclysm that ended the previous world. Water that rose without warning or with barely enough warning for a chosen few to survive. A world before the water and a different world after it. These stories come from Mesopotamia, from the Hebrew Bible, from Hindu scripture, from the oral traditions of Aboriginal Australians, from the mythology of the Aztecs and the Maya, from the legends of the Hopi, the Cree, the Inuit, from Chinese, Korean, and Japanese folklore, from the island cultures of the Pacific, from the tribal narratives of sub-Saharan Africa. 500 independent versions documented by anthropologists and folklorists across 3 centuries of fieldwork, in cultures that had no documented contact with each other, separated by oceans, by continents, by thousands of years of independent development, all telling the same story. The standard academic explanation is straightforward. Floods are a universal human experience. Every civilization settles near water. Every civilization experiences flooding. The flood myth is a natural response to a recurring natural phenomenon. That explanation sounds reasonable. It is also inadequate because 500 cultures did not independently invent the same specific narrative structure. The flood myths do not simply describe a river overflowing its banks or a coastal storm surge swamping a village. They describe a sequence, a previous world that existed before the water, a catastrophic inundation so total that it redefined the boundary between the old reality and the new one. A survivor, often warned in advance, who preserves life or knowledge through the deluge, a new beginning on the other side. That is not a generic flood story. That is an account of a specific category of event with a specific narrative architecture. And when 500 independent sources across every inhabited continent describe the same specific sequence, the explanation that they all invented it separately requires a more extraordinary coincidence than the explanation that they all remember the same thing or the same category of thing. What the geology tells us happened between 15,000 and 7,000 years ago is exactly the kind of event that would leave this memory in every coastal culture on Earth. Here is the number that most people have never been asked to hold in their minds: 120 meters. That is how much the global sea level rose between the end of the last ice age and the stabilization of modern coastlines. 120 meters, roughly the height of a 40-story building, an entire vertical column of ocean that did not exist on the continental shelves during the Ice Age and does exist there now. That rise was not a single event. It unfolded over approximately 8,000 years between roughly 15,000 and 7,000 years ago, driven by the melting of the massive ice sheets that had covered much of North America, Northern Europe, and parts of Asia during the last glacial maximum. But the rise was not steady. It came in pulses. Periods of relative stability punctuated by rapid surges when large sections of ice sheet collapsed suddenly into the ocean. One of the most dramatic pulses occurred around 14,000 years ago. In a span of a few centuries, sea levels jumped by roughly 20 meters. Another major pulse may have coincided with the events of the Younger Dryas 12,800 years ago, when the catastrophic disruption could have destabilized ice sheets and triggered rapid coastal flooding in multiple regions simultaneously. To understand what 120 meters of sea level rise means in human terms, you need to stop thinking about it as a number and start thinking about it as a landscape. During the last ice age, the coastlines of every continent were miles further out than they are today. The continental shelves, the shallow underwater platforms that extend from the current shorelines out to the deep ocean, were dry land. Rivers flowed across them. Forests grew on them. Animals grazed on them, and humans lived on them. Not in small numbers. Coastal zones are the most productive environments on Earth. They provide access to marine protein, fresh water from river deltas, fertile soil from alluvial deposits, and natural transportation corridors along waterways. In every period of human history for which we have detailed records, the largest and most complex settlements have been coastal. There is no reason to believe the Ice Age was different. The most populated, most developed, most interconnected human communities of the Pleistocene were almost certainly located on the coastal plains and river deltas of the continental shelves, all of which are now underwater. Put yourself on one of those coastlines in 12,000 years before the current era. Your community has been there for generations. Your grandparents were born there. The stories they told about their grandparents were set there. The geography of your world, the location of your sacred sites, your burial grounds, your fishing territory, your trading routes, your seasonal patterns, all of it is anchored to a landscape that you have no reason to believe will ever change. And then the sea starts moving, not overnight, not in a single catastrophic wave, though the pulses may have felt catastrophic to the people who experienced them. The water advances. Some years the change is barely noticeable. A high tide that reaches further than it did the year before. A low-lying area near the river mouth that stays flooded longer each spring. Then a pulse hits. The water rises faster. The low ground floods and does not drain. The beach where the children played last summer is a tidal flat this summer and open water the summer after. The fishing grounds shift. The freshwater springs near the coast turn brackish and then salt. Your children grow up watching the sea eat the world. Their children grow up in a world already smaller than the one their parents described. And their children grow up with stories about a time before when the coast was further out, when the land was wide. When the old places still existed down there under the water, where you can sometimes see shadows on the seabed when the light is right and the water is calm. Those stories get told for 1,000 years, then 2,000, then 5. They get compressed. The gradual process of generational coastal loss becomes a single catastrophic event in the retelling. Because that is how human memory works with inherited trauma. Complexity collapses into simplicity. A century of rising water becomes a flood that came in a night. The narrative crystallizes. The details change with each culture, but the structure remains. A world before, a flood. Survivors, a new beginning. 500 versions of this story are not 500 independent inventions. They are the accumulated, compressed, mythologized memory of one of the largest geographical transformations in human history. The sea ate an entire world's worth of coastline. The memory of it outlasted every physical trace of the world that was lost. And the geological evidence confirms every element of that memory. The sea level data is precise. It comes from coral cores, from coastal sediment analysis, from the dating of submerged shoreline features, from the chemistry of marine organisms whose shells record the salinity and temperature of the water they grew in. The 120-meter rise is not an estimate. It is a measurement replicated by independent methods across multiple ocean basins. The rapid pulses are documented. They are visible in the coral record and have a distinct acceleration datable to within a few centuries. The flooding of specific regions has been mapped. The North Sea Basin, which connected Britain to continental Europe as dry, walkable land during the Ice Age, a landscape archaeologists have named Doggerland, flooded progressively throughout this period. It was a vast, low-lying plain crossed by rivers, dotted with lakes, rich in game and plant life. People lived there, they hunted there, they built communities there. And then over the course of a few thousand years, the North Sea filled it in. By roughly 8,000 years ago, it was gone. Britain became an island. A landscape the size of a small country vanished beneath the waves. The Black Sea Basin tells a similar story with an even more dramatic ending. During the Ice Age, the Black Sea was a freshwater lake, smaller than it is today, sitting well below the level of the Mediterranean. Around 7,500 years ago, as Mediterranean sea levels rose, water breached the narrow land barrier at what is now the Bosphorus Strait. The breach may have been gradual, or it may have been sudden. Some geological models propose a catastrophic inundation, a wall of salt water pouring through the breach at a rate of roughly 200 times the flow of Niagara Falls, flooding the basin and displacing every community that had settled along its shores. This event has been proposed by marine geologists as a regional origin point for multiple Near Eastern flood traditions, including the story that eventually became the biblical account of Noah. Whether or not the Black Sea flood was as sudden as the most dramatic models suggest, the geological fact is not in dispute. The basin flooded. The freshwater lake became a saltwater sea. The communities that lived along its shores were displaced. The memory of that displacement entered the oral traditions of the cultures that survived it. The land area lost to the rising ocean between 15,000 and 7,000 years ago was roughly equivalent to the combined landmass of Europe and North America. That is the scale of what disappeared. Not a riverbank, not a delta, a continental expanse of inhabited land, home to thousands of years of human settlement, cultural development, and accumulated knowledge. Swallowed by the ocean at a pace that individual human lifetimes could perceive and remember. And we have barely begun to look at what lies beneath the water, where that land used to be. Underwater archaeology of the continental shelves is one of the most underfunded and underexplored areas in the study of human history. The technology exists: side-scan sonar, remotely operated submersibles, diving operations capable of working at depths of dozens of meters. All of these tools are available and have been used to stunning effect in the handful of locations where they have been deployed. In the Gulf of Cambay, off the western coast of India, sonar surveys have identified what appears to be a submerged settlement at a depth of approximately 40 meters. Geometric patterns on the seabed consistent with structural foundations. Artifacts recovered from the site have been dated to roughly 9,500 years ago. If confirmed, this would be one of the oldest urban-scale settlements ever discovered, predating the earliest known cities of Mesopotamia by thousands of years. And it is underwater, buried under 4,000 years of marine sediment in a region that was dry coastal land during the period when the settlement appears to have been occupied. Off the southern coast of Japan, near the island of Yonaguni, divers discovered a massive submerged rock formation with features that some researchers argue are too geometric, too regular, too precisely stepped to be natural geological formations. The Yonaguni Monument, as it has come to be called, remains controversial. Geologists point to natural fracturing processes in the local sandstone that can produce step-like formations. Proponents point to specific features, right-angle cuts, symmetrical terracing, what appear to be carved channels that they argue exceed the capacity of natural fracturing to produce. The debate continues, but the debate itself is instructive. We are arguing about whether a submerged structure off the coast of Japan is natural or artificial, and we are doing so without having conducted anything resembling a comprehensive archaeological survey of the continental shelves where Ice Age coastal civilizations would have existed. Off the coasts of the Mediterranean, researchers have found submerged Neolithic settlements, villages with stone walls and organized floor plans sitting on the seabed at depths that correspond to the coastline positions of 8,000 to 10,000 years ago. Off the coast of Albania, off the coast of Israel, off the coast of southern France. Each discovery treated as an isolated curiosity rather than as evidence of a systematic pattern. The pattern being that the most inhabited coastal zones of the Ice Age world are underwater, and we have explored a vanishingly small percentage of them. We have spent billions of dollars and decades of effort searching for signs of microbial life on Mars, a planet that has been geologically dead for billions of years, with no atmosphere, no liquid water, and no biological history that we have been able to detect. Meanwhile, the drowned coastlines of our own planet, accessible with current technology, known to have been inhabited by human populations for tens of thousands of years, containing the archaeological record of the coastal civilizations of the Ice Age world, remain largely unexplored. The reasons are not scientific. They are institutional. Underwater archaeology is expensive, logistically complex, and falls between the jurisdictional boundaries of terrestrial archaeology, marine geology, and oceanography. Funding agencies do not have clear categories for it. Academic departments are not structured to support it. The career incentives push researchers toward land-based excavation where the methods are established, the costs are lower, and the publication pipelines are well-defined. The result is a blind spot the size of a continent. We know the land was there, we know people lived on it, we know the sea took it. We know the memory of that loss survives in the oldest stories humanity possesses, repeated 500 times across every inhabited continent. And we have not seriously looked at what is sitting on the seabed where that land used to be. What are we going to find when we actually look? The flood myths are not evidence of a supernatural event. They are evidence that human populations with oral traditions witnessed geological events large enough to define the boundary between their old world and their new one. The geology confirms the events were real. The myths confirm the events were remembered. The question is not whether the stories describe something that actually happened. The geology settles that. The question is, what else is in those memories that the geology cannot tell us directly? What knowledge did the people who lived on those drowned coastlines carry with them when the water forced them inland? What did they know about the world before the flood? What did they preserve and what did they lose? That is a question that will never be answered because the people who lived on those coastlines are gone. Their settlements are underwater. Their artifacts are buried. Their knowledge is lost, except for the stories. The stories survived. The stories spread. 500 cultures told them independently. And we are only now beginning to understand that those stories are not myth. They are memory. They are geology turned into narrative. They are the oldest record of catastrophe that humanity possesses. We have now traced a line that connects the chemistry of 56-million-year-old rock to the oral traditions of cultures that remember a world the ocean swallowed. We have seen patterns in the evidence that suggest a previous civilization may have existed and left a chemical fingerprint that we cannot distinguish from natural causes. We have seen the physical markers of a cosmic impact 12,800 years ago. We have seen monuments built by people who understood that catastrophe was coming and left messages in stone for whoever came after. We have seen the geological evidence of a rising ocean that swallowed entire continents and the mythological memory of that catastrophe preserved by hundreds of independent cultures. All of this points to a single, uncomfortable conclusion. We are not unique. We are not the first. Something was here before us, and it may have left the same kind of fingerprint we are currently producing. In the next chapter, we turn the lens inward and face the most uncomfortable connection of all. Because the carbon we are pumping into the atmosphere right now carries the same isotopic signature, follows the same trajectory, and is approaching the same thresholds that define the beginning of the most severe climate event in the last 66 million years. And the question that no one wants to answer is whether we are watching history repeat itself or whether we are the ones writing the repetition. Here is the number that turns everything we have discussed from a story about the past into a warning about the present. The rate of carbon dioxide increase in the atmosphere right now, measured in parts per million per year, is faster than at any point in the last 800,000 years of ice core data. Not approximately faster, measurably, unambiguously, record-breakingly faster. The instruments tracking atmospheric composition at the monitoring stations show a concentration that has risen from roughly 280 parts per million before the Industrial Revolution to over 420 parts per million today, an increase of 50% in roughly 2 centuries. And the isotopic signature of that carbon, the fingerprint locked into every molecule of carbon dioxide we have added to the atmosphere, is biological, light carbon. Carbon-12 enriched, the unmistakable chemical marker of burned ancient organic material, coal, oil, natural gas, biological deposits that accumulated in the Earth's crust over hundreds of millions of years, extracted and combusted in a geological instant. The same fingerprint as the Paleocene-Eocene thermal maximum. Not similar, not analogous, chemically identical. The carbon-12 to carbon-13 ratio of our industrial emissions falls within the same range as the isotopic excursion recorded in the PPTM boundary layer. A geochemist analyzing a sediment sample from the bottom of the ocean 50 million years from now would not be able to distinguish our carbon signal from the one that caused one of the most severe extinction events of the past 66 million years. The source is the same. Burned biological carbon, the delivery mechanism is the same. Rapid release into the atmosphere over a geologically brief window. The isotopic fingerprint is the same, a sharp negative excursion in the carbon-13 ratio, globally distributed, unmistakable, permanent in the geological record. We are not approaching the PTM, we are reproducing it in real time with full awareness of what we are doing. Now let us be precise about the comparison, because precision matters here. The PTM released between 3 and 7 trillion tons of carbon over a period of roughly 3 to 20,000 years, depending on which estimate of the release rate you use. Human industrial activity has released roughly 700 billion tons of carbon since the beginning of the Industrial Revolution. We are not yet at PTM total volumes, but we are at the beginning of the trajectory. The rate at which we are adding carbon to the atmosphere is comparable to the fastest estimates of the PM release rate. Some recent analyses suggest our current rate may actually exceed the peak ETM rate, though the uncertainty in the ancient data makes precise comparison difficult. What is not uncertain is the direction: up, fast, with a fingerprint that matches. The temperature projections reinforce the parallel. Global average temperature has already increased by approximately 1.2 degrees Celsius since the pre-industrial baseline. Current trajectories based on existing emissions commitments and realistic assessment of how quickly the global energy system can transition project an increase of 2 to 4 degrees by the end of this century. The PPM produced a temperature increase of 5 to 8 degrees over the course of the event. We are at the low end of that range and accelerating. The question is not whether we will reach PTM temperatures. It is how far along the path we travel before the feedbacks take control, because the feedbacks are the part that makes the PTM comparison truly frightening. The PETM was not caused by a single pulse of carbon that then dissipated. The initial carbon release, whatever its source, triggered a cascade of secondary releases that amplified and sustained the warming for tens of thousands of years. The warming destabilized methane hydrates on the ocean floor, releasing additional greenhouse gases. The warming thawed permafrost in high-latitude regions, releasing stored carbon that had been locked in frozen soil for millennia. The warming reduced ice coverage, which reduced the planet's reflectivity, which caused it to absorb more solar energy, which caused more warming. Each feedback strengthened the others. The system crossed a threshold beyond which the warming became self-sustaining, independent of whatever initiated it. And it took 200,000 years for the Earth's natural carbon sequestration processes, the slow work of rock weathering and biological carbon burial, to draw the excess carbon back out of the atmosphere and restore equilibrium. Every one of those feedbacks is present in the current climate system. Every one of them is already showing signs of activation. Permafrost across the Arctic is thawing at rates that exceed the projections of climate models from even a decade ago. The permafrost contains an estimated 1.5 trillion tons of organic carbon, roughly twice the amount currently in the atmosphere. As it thaws, microbial decomposition converts that stored carbon into carbon dioxide and methane, which enter the atmosphere and accelerate the warming that caused the thawing. The feedback loop is already running. Methane hydrates on the ocean floor remain stable as long as the water above them stays cold enough. As ocean temperatures rise, the stability boundary shifts. Hydrate destabilization has already been observed in shallow Arctic marine sediments. The total volume of carbon stored in global methane hydrate deposits is estimated at between 1 and 5 trillion tons. If even a fraction of that enters the atmosphere, the effect on global temperature would be measured in degrees, not fractions of degrees. Arctic sea ice is declining. The ice reflects roughly 80% of incoming solar radiation back into space. Open ocean absorbs roughly 90%. Every square kilometer of ice that melts and is replaced by open water converts the surface from a reflector to an absorber. The system warms faster. More ice melts, more open water appears, more heat is absorbed. The albedo feedback loop has been documented for decades. Its acceleration in recent years has exceeded the predictions of most climate models. And here is the element that connects the climate science directly to the Silurian hypothesis and the PTM. We do not know where the tipping points are. We know they exist. We know the PTM crossed one because the warming sustained itself for 200,000 years after the initial carbon input ended. We know the Earth's climate system has tipping points, thresholds beyond which the feedbacks become self-reinforcing and the system shifts to a new equilibrium state regardless of what triggered the initial change. But we do not know how close we are to those thresholds. We cannot see them from this side. The PTM shows us what the other side looks like: mass extinction of deep-sea organisms, acidification of the global ocean, temperature increases sufficient to make large portions of the planet's surface uninhabitable for the species adapted to pre-event conditions, a recovery period longer than the entire history of Homo sapiens. That is what happens when the system crosses the threshold. And we are approaching that threshold at a rate that the geological record says is comparable to the rate that triggered the crossing 56 million years ago. If the Silurian hypothesis is even partially correct, if some component of the PEM carbon signal was produced by an industrial process that we cannot distinguish from natural causes at this temporal distance, then the PETM is not just a climate event. It is a precedent, a record of what happens when a civilization on this planet overshoots its carbon budget. The event peaked, the temperature maxed out, the extinctions happened, and then slowly over 200,000 years, the system recovered. Whatever produced that carbon signal did not survive to see the planet stabilize. There is no second chapter in their record, no recovery story, just a layer in the rock and an open question. And here we are writing the same layer with the same fingerprint at the same rate, with instruments precise enough to watch ourselves do it in real time. The question that sits at the center of this parallel is not a scientific question. It is a civilizational one. We are the first species in Earth's history that can read the geological record of what happened before us and understand what it means for what we are doing now. The PTM data is available. The Silurian hypothesis has been published. The climate science is not ambiguous. The feedbacks are documented. The trajectories are modeled. The thresholds are theoretically understood. Even if their exact locations are unknown, we know the difference. Whatever caused the PTM, whether it was a previous civilization or an entirely natural cascade, the entity that produced that carbon signal almost certainly did not have the capacity to read a 56 million-year-old geological record and recognize its own reflection in it. We do. We can look at the PTM boundary layer in a sediment core and see with molecular precision what we are currently producing. We can measure our own carbon output, calculate its isotopic signature, project its trajectory, and compare it directly to the signal that preceded one of the worst extinction events in recent Earth history. And the comparison is not reassuring. The institutional response to this comparison is the same institutional response we have encountered at every stage of this story. Careful acknowledgement, extensive study, a conspicuous absence of the most direct conclusion the data supports. Climate scientists know what the carbon curve looks like. They publish papers with carefully worded assessments of risk. They present at conferences. They advise governments. And they watch as the emissions curve continues upward year after year, decade after decade, through every international agreement and every promised transition. The gap between knowledge and action is not new in human history. But the gap between knowledge and action, when the knowledge includes a direct geological precedent for civilizational collapse, is something that has never existed before. We are the first. And what we do with that distinction will determine what the next reader of the geological record finds when they look at our layer, because there will be a next reader. That is one of the few certainties in this entire story. The Earth will not stop being habitable. Even the PTM, as devastating as it was temporary. The planet recovered. Life continued. New species filled the niches left empty by the extinctions. New ecosystems assembled themselves from the survivors. Given enough time, measured in the tens of millions of years that the Earth has ahead of it before the sun begins its expansion into a red giant, the conditions for complex life will reassert themselves. Intelligence may appear again. perhaps from primates, perhaps from corvids, perhaps from cephalopods, perhaps from a lineage we cannot predict. And when it does, when the next species with the cognitive capacity to read chemistry develops the instruments to analyze ancient rock, they will find our layer. A thin band of isotopically light carbon, a sharp negative excursion in the carbon-13 ratio, anomalous concentrations of trace metals at specific global locations, a possible radioactive signature requiring explanation. They will study it the way we study the PTM. They will model the natural mechanisms. They will calculate the volume, and they will find, as we have found, that the numbers do not quite add up. Some researcher among them, someone with the intellectual courage that previous scientists showed when they asked uncomfortable questions, will publish a paper asking, could this layer represent the output of an industrial civilization that existed at this point in Earth's history? They will run the same models. They will reach the same conclusion. We would not be able to tell. And they will look at the chemistry in our layer and note that it fits. Then they will wait for the response from their field, and the response, if their institutional structures bear any resemblance to ours, will be the same. Acknowledgement. Citation. Silence. Because the conclusion is uncomfortable. Because admitting that something was there before them means admitting that the universe runs this experiment more than once, and that running it more than once does not guarantee a different outcome. We are going to be someone else's unanswered question, someone else's gap in the literature, someone else's uncomfortable hypothesis sitting in a journal with a handful of citations and years of institutional silence. The only thing we do not know is whether they will be asking the question because we left just the chemical layer, or because we left the chemical layer and survived to leave something more. What separates those two outcomes is not technology. It is not intelligence. It is not even knowledge, because we already have the knowledge. What separates them is what we choose to do with the knowledge in the brief window between recognizing the pattern and the pattern completing itself. That window is now. Not a century from now, not next decade. The feedbacks are activating. The trajectory is set. The distance between where we are and where the PTM crossed its threshold is measured not in centuries, but in the decisions made by the generation currently alive. This generation, the one listening to these words, the one that knows with a certainty no previous generation has possessed exactly what it is writing into the rock. Something was here before us. Maybe the data fits. The gaps are real. The framework that connects them has been published, peer-reviewed, and largely ignored. That is the honest state of the evidence. Not a conclusion, not a verdict. An open question whose openness is itself a statement about how we handle ideas that challenge the story we have agreed to tell ourselves about our place in the history of this planet. But here is what is not, maybe. Here is what is confirmed, measured, replicated, and beyond any reasonable dispute. The geological record does not make exceptions. It has processed every civilization, every species, every ecosystem that has ever existed on this planet with the same indifference. Chemistry survives. Everything else degrades. Whatever came before us, if anything did, left a layer. And the layer either has an explanation we have found or an explanation we have not found yet, or an explanation that makes us deeply uncomfortable about what it implies. We are leaving a layer right now. Think about what that means, not abstractly, not as a metaphor, physically. The carbon from your car's exhaust, the carbon from the power plant that charged the device you are listening to this on, the carbon from the factory that made the food you ate this morning. Every molecule of that carbon carries an isotopic fingerprint, light carbon, carbon-12 enriched, the unmistakable chemical signature of burned ancient biological material. That carbon enters the atmosphere. It dissolves into the ocean. It is incorporated into the calcium carbonate shells of microscopic marine organisms living in the surface waters. Those organisms die. Their shells drift downward through thousands of meters of dark to the seabed. They accumulate in sediment that compresses over millions of years into limestone. And the isotopic fingerprint of the carbon they incorporated is preserved in that stone permanently, written into the geological record with a fidelity that no human archive, no digital storage system, no library can match. The rock does not forget, the rock does not interpret, the rock records, and what it is recording right now at this moment in sediment accumulating on the floors of every ocean on Earth is us. Our energy choices, our consumption patterns, our collective decision about how much ancient carbon to extract and burn in the brief window of time we occupy. The layer is being written, the fingerprint is being set, and once it is in the rock, it stays there for as long as the rock exists. Here is the inventory of everything we will leave behind that a future reader could detect after 50 million years of geological processing. A carbon isotope excursion. A sharp negative shift in the carbon-13 ratio, globally distributed, rapid in onset, large enough to be clearly distinguishable from background variation. This will be the clearest and most durable signal of our existence. It will outlast every building, every road, every satellite, every work of art, every written record. The last thing to survive of human civilization will be the chemical evidence of the carbon we burned. Anomalous trace metal concentrations. At the locations where our cities stood, where our mines operated, where our industrial facilities processed materials, certain metals will be concentrated in a thin sediment layer at levels above their natural background distribution. Lead, copper, zinc, rare earth elements, cadmium, mercury. These concentrations will persist as subtle anomalies in the rock. A future geochemist with precise enough instruments could detect them. But without context, without any surviving structure or artifact to connect the chemistry to, those anomalies will look like natural mineral deposits. They will be cataloged. They will not be understood. A possible radioactive signature. The isotopes from nuclear testing and nuclear energy production have half-lives ranging from thousands to millions of years. After 50 million years, even the longest-lived products will have decayed to levels that are very difficult to distinguish from natural background radiation. But some anomalous isotope ratios at specific locations, the sites of reactors and detonations, might persist as faint, puzzling readings in the rock. Without a framework for interpretation, they will remain puzzling. That is the complete list. Carbon chemistry, trace metals, a possible whisper of radiation, no structures, no artifacts, no images, no language, no names, no indication that the entities who produced these chemical signals were aware of their own existence, let alone capable of contemplating the permanence of the record they were writing. Just numbers in a thin band of rock. Now look at what the PTM left behind. A carbon isotope excursion, a sharp negative shift in the carbon-13 ratio, globally distributed, rapid in onset, with a volume that exceeds the known natural explanations. Anomalous trace concentrations in the boundary layer that are still being cataloged and characterized. A chemical record that has been studied for 30 years and still contains a gap that no one has closed. The inventory is the same. The fingerprint is the same. The format is the same. The only difference is 56 million years of time, and the open question of whether the entity that left the earlier signal knew what it was doing. We know what we are doing. That is the line that separates us from every previous entry in the geological record. We are the first civilization in Earth's history that possesses the instruments to measure its own impact on the planet's chemistry in real time. We are the first to read the record of what happened before us and understand the implications. We are the first to build the models that predict where the current trajectory leads. We are the first to have the uncomfortable hypothesis in a peer-reviewed journal, telling us in explicit terms that a vanished civilization's footprint would look exactly like the anomalies we find in ancient rock. We are the first to see the pattern, and seeing the pattern has not changed the pattern. That is the fact that sits at the center of this entire story. Not the PM, not the Younger Dryas, not the monuments or the Sphinx or the underground cities or the flood myths or the drowned coastlines. All of those are pieces of a puzzle whose shape we can now see clearly enough to describe. The piece that defines this moment, the piece that will determine what our layer says to whoever reads it, is the gap between knowing and acting. We have crossed the threshold of knowledge. We have not crossed the threshold of response. Think about the people who built Göbekli Tepe. They had just survived the end of a world. They had watched the sky do something catastrophic. They had lost people, communities, entire ways of life, and their response was to build, not for themselves, for whoever came next. They encoded the date of the catastrophe in the geometry of the stars. They carved it into stone weighing 10 tons. They organized hundreds of people, invented agriculture to feed them, and spent generations constructing a message they knew they would never see delivered. And then they buried it to make sure it survived. They did not have writing. They did not have metal tools. They did not have any of the advantages we take for granted. What they had was the knowledge of what had happened and the conviction that someone in the future needed to know it. 2, they acted on that knowledge with everything they had. They left a message in stone that lasted 12,000 years and was only discovered in 1994. 12,000 years. A message in stone from people with no technology, no infrastructure, no institutional support, designed, built, and preserved with nothing but human effort and the absolute certainty that the information mattered enough to justify the cost. Now look at us. We have the information. We have the technology. We have the institutional structures, the scientific knowledge, the computational power, the engineering capacity, and the global communication networks to act on what we know at a scale and speed that the builders of Göbekli Tepe could not have imagined. And the layer we are writing into the rock says that we are not acting. The carbon curve is still rising. The feedbacks are still activating. The trajectory has not changed. The layer is getting deeper. What will it say about us? That is the question this story leaves you with. Not whether something was here before us. That question may never be answered with certainty because the geological record is structurally incapable of preserving the answer. The question that matters, the question that has a definite answer that is being written right now, is what our layer will say about us. Will it say that we were the first civilization to see the pattern and change course, that we recognized our own fingerprint in the rock of the deep past and chose a different trajectory? That the knowledge made a difference? Or will it say what the PM layer says? A spike, a warming, an extinction horizon, and then slowly over 200,000 years, a recovery with no indication that whatever produced the signal survived to see the planet stabilize. The Milankovitch cycles will continue. The Earth's orbital parameters will shift on their long, predictable schedules, adjusting the energy balance of the climate system over tens of thousands of years. The next glacial period will eventually arrive regardless of what we do. The planet will continue its geological processes, its tectonic recycling, its slow reshaping of continents and ocean basins. In 100 million years, the geography of the Earth will be unrecognizable. The continents will have drifted into new configurations. The ocean basins will have reshaped themselves. The rock we are writing our signal into will have been folded, uplifted, subducted, compressed, and rearranged by forces that operate on timescales so vast that human civilization occupies less than a single pixel in the image. But the chemistry will survive. Somewhere in a layer of limestone that was once sediment on the floor of a deep ocean, the isotopic signature of our carbon will persist. Light carbon, rapid, global, with a fingerprint that points unmistakably to burned biological material. It will be there when the next reader arrives. It will be there when someone develops the instruments to analyze it. It will be there when someone asks the question, what was this? What caused this? What happened to whatever produced it? And the answer to that question, the one we are writing right now, is not yet finished. It is being composed in every power plant that fires up, in every forest that burns, in every policy decision that delays the transition, in every barrel of oil that is extracted and burned, and in every choice, every investment, every demand, every vote that either accelerates the trajectory or bends it toward something other than what the PTM trajectory produced. The layer is not sealed. The entry is not complete. The last line has not been written. Something was here before us. We do not know what it was. We do not know if it knew what it was doing. We do not know if it saw the threshold approaching or crossed it in ignorance. We do not know if it left a warning. We do not know if we would recognize the warning if it did. But we know what the record shows: a fingerprint, a gap, a temperature spike, an extinction, and a 200,000-year silence before the planet found its balance again. We are not going to be a mystery to whoever comes next. We are going to be a data point, a layer of chemistry with a fingerprint they will recognize because it will look exactly like the one we have spent decades studying and thoroughly discussing. The only variable that is still open, the only thing that separates a layer that tells a story of recognition and change from a layer that tells a story of recognition and repetition, is what we do between the moment we understand the pattern and the moment the pattern completes itself. The builders of Göbekli Tepe understood something we have been slow to learn. Knowledge that is not acted upon is not knowledge. It is decoration. They knew the sky had fallen. They built in response. They carved the date into stone. They buried it underground. They spent generations and invented agriculture to make sure the message survived. They did not have our advantages. They did not have our resources. They did not have our understanding of the mechanisms. What they had was the clarity that comes from having lost everything, and the resolve to make sure the loss was not meaningless. We have not lost everything. Not yet. And whether or not we do depends on whether we treat the pattern as information or as a warning. The rock is waiting, the layer is being written, the fingerprint is being set, and somewhere in 50 million years, someone is going to find it. Hold the question in your mind as you leave this story, not the question of what was here before us, the question of what we want our layer to say, because the record is patient. The record does not judge, the record does not hope. It simply records what happened in the chemistry of ancient rock with a fidelity that nothing else in the universe can match. And the entry it is recording right now, the one that will carry our name, whether we intended it to or not, is still being written. The rock is waiting. The layer is being written. The fingerprint is being set. And somewhere in 50 million years, someone is going to find it. Hold the question in your mind as you leave this story, not the question of what was here before us, the question of what we want our layer to say. Because the record is patient. The record does not judge. The record does not hope. It simply records what happened in the chemistry of ancient rock with a fidelity that nothing else in the universe can match. And the entry it is recording right now, the one that will carry our name, whether we intended it to or not, is still being written. What do you want it to say? Consider for a moment what we have done with the knowledge we possess. We have read the geological record. We have understood the mechanisms. We have calculated the feedbacks. We have built models that predict with reasonable confidence what happens when a planet crosses certain thresholds of atmospheric carbon. We have done all of this with extraordinary precision. We have invented instruments sensitive enough to measure isotope ratios in sediment cores drilled from the ocean floor. We have developed computational systems capable of simulating climate dynamics across hundreds of thousands of years. We have created satellites that monitor the composition of the atmosphere in real time. We possess the technological capacity to see ourselves writing this layer into the rock as we write it. And yet the carbon curve continues upward, not because we lack the knowledge, not because we lack the technology, not because we lack the resources. We have all of these things in abundance. The barrier is not material. It is not intellectual. It is institutional and psychological. It is the gap between understanding a problem and having the will to act on that understanding at the scale and speed required. That gap has always existed in human affairs, but never before has it existed in the presence of this much clarity about the consequences. The people who built Göbekli Tepe did not have the advantage of reading a 56 million year old geological record. They did not have climate models or atmospheric measurements. They did not have the scientific framework to understand the mechanisms of what had happened to them. What they had was the immediate visceral memory of catastrophe. They had watched their world end. They had seen the sky do something that killed everything around them. And that knowledge, raw and unfiltered by scientific uncertainty, motivated them to act. They built a message. They encoded information about what had happened. They preserved it in stone and buried it because they understood that the next catastrophe could come at any time. And they wanted whoever survived it to know that this had happened before. We have all of that knowledge, plus everything they lacked. We have the data. We have the models. We have the instruments. We have the framework. And we have something else they did not have. We have the precedent. We have the PPTM sitting in the geological record telling us exactly what happens when a carbon event of this magnitude plays out. We can read it, we can understand it, we can compare it directly to what we are currently producing. And the comparison tells us that we are on a trajectory that ends in the same place the PETM ended. Not definitely, not inevitably, but with high probability if we do not change course. Yet the response from our institutions, from our governments, from our collective decision-making apparatus has been what? Acknowledgement. Yes, we see the problem. Careful study. Yes, we are researching it extensively. Incremental policy adjustments. Yes, we are making small changes. And then continued acceleration down the same path. The emissions curve keeps rising. The feedbacks keep activating. The trajectory remains locked in the same direction it has been locked in for decades. We have moved the needle slightly. We have made cosmetic adjustments. We have done everything except the one thing that would actually change the outcome. We have not acted at scale. This is not a failure of knowledge. This is a failure of will. And it is perhaps the most significant failure of will in human history, because it is the first time we have possessed this much clarity about what the failure means. Previous civilizations that collapsed due to environmental stress were often operating without complete information about what was happening to them. They were making decisions based on incomplete data, cultural inertia, institutional resistance to change. We cannot make that claim. We have the complete data. We understand the mechanisms. We can model the outcomes. We know what the layer we are writing will look like 50 million years from now, and we are writing it anyway. There is a question that sits beneath all of this, one that I have circled around but not directly addressed. What if the Silurian hypothesis is correct? What if some previous civilization did exist on this planet and did produce the carbon signal we see in the PDM? What would that mean for us? How should that knowledge change our behavior? The answer, I think, is that it should change everything about how we see ourselves and our moment in history. Because if the Silurian hypothesis is even partially correct, if there is any meaningful probability that the PETM was produced by industrial activity rather than entirely natural causes, then we are not the first to face this choice. We are not the first civilization to discover that burning stored carbon at scale leaves a mark on the planet. We are not the first to understand the consequences. We are not the first to fail to change course despite that understanding. We are simply the first to know that we are not the first. That is the distinction that matters. Every previous civilization that may have faced this threshold did so in ignorance of what other civilizations had done before them. They could not read the geological record the way we can. They could not compare their trajectory to a precedent. They could not say to themselves, this is what happened 50 million years ago, and this is what happened to the civilization that produced it. They were writing their own layer without knowing that a similar layer already existed deeper in the rock. We do not have that excuse. We can read both layers, we can see the pattern, we can understand what it means, and we are making the same choices anyway. That is the most damning indictment of our moment that I can articulate. Not that we are facing a catastrophic climate crisis, not that we are destabilizing the planetary systems that support complex life, not that we are driving species toward extinction. All of those things are terrible and true and important. But the most damning fact is that we possess knowledge of a precedent and we are ignoring it. The question of whether the PEM was produced by a previous civilization or by natural causes may never be definitively answered. The geological record is structurally incapable of providing that answer. But the question of whether we will change our behavior in response to the knowledge that we might be repeating a pattern that played out 56 million years ago, that question has an answer. It is being written right now. And the answer so far is no. We are not changing our behavior. We are acknowledging the pattern and continuing to reinforce it. This is not inevitable. The outcome is not predetermined. The layer we are writing is not sealed. There is still time to change the trajectory. There is still a window, growing smaller with each passing year, in which meaningful action at scale could alter the course we are on. The feedbacks are activating, but they have not yet become irreversible. The system has not yet crossed the threshold where the warming becomes self-sustaining, independent of what we do. We still have agency. We still have choices. What we lack is not capability. We lack motivation. And that lack of motivation is precisely the thing that the PTM and the Silurian hypothesis should be providing. If we know that a previous civilization may have faced this exact threshold and crossed it, and if we know what crossing that threshold means, why are we still walking toward it? Why is the carbon curve still rising? Why are we still extracting and burning fossil fuels at an accelerating rate? Why are the institutions that have the power to change this trajectory still locked in patterns of incremental adjustment and careful study? The answer lies in the structure of how we make collective decisions. The problem is not that we lack the knowledge or the technology. The problem is that the incentive structures that govern individual and institutional behavior are not aligned with the survival of the civilization. A politician who advocates for radical economic transformation to address climate change faces immediate political costs and uncertain benefits. A corporate executive who voluntarily transitions away from fossil fuel production faces shareholder pressure and competitive disadvantage. An academic researcher who challenges the dominant narrative around climate action faces professional isolation. The individual cost calculations all point toward maintaining the status quo, but these individual cost calculations are made in the context of a collective cost that is being borne by everyone. The costs of inaction are distributed diffusely across the entire human population and across future generations. The costs of action are concentrated sharply on specific actors and institutions. This asymmetry is fatal to the possibility of change at the scale we need. Everyone waits for someone else to move first. Everyone calculates that their individual small actions do not matter compared to the actions of others. Everyone defers to institutions that are themselves locked in the same calculation. The builders of Göbekli Tepe did not have this problem. They were operating in the immediate aftermath of catastrophe. The costs of inaction were not distributed or abstract. They were concrete and immediate. Every person who lived through the Younger Dryas or its aftermath knew what had happened. They carried the memory of it in their bodies and in the stories they told. The motivation to build, to preserve, to create a message that would survive the next catastrophe was not dependent on calculating distant probabilities. It was rooted in direct experience of the threshold crossing. We do not have that advantage. We are trying to motivate action based on reading a story in a rock that is 56 million years old. We are trying to convince people to fundamentally restructure their lives and their societies based on models and projections and carefully worded scientific assessments of risk. This is a much harder sell than the direct experience of watching your world end. It is also, unfortunately, the only sell we have. The question then becomes not whether we have the knowledge or the capability to change course. The question becomes whether we have the social and institutional capacity to translate that knowledge into action before the point at which action becomes impossible. That is the race we are actually in, not a race between climate change and our technology, not a race between rising emissions and carbon sequestration, a race between our institutional and cultural capacity to change our behavior and the physical activation of the feedbacks that make change irrelevant. The feedbacks are already activating. Permafrost is thawing, methane is being released, ice is melting, the albedo effect is reducing the planet's reflectivity. These are not theoretical concerns. These are measured physical processes currently happening on a planet that we inhabit. The question is whether we can reduce emissions fast enough to prevent the activation of the positive feedbacks from becoming irreversible. And every year that we delay, that window gets smaller. Scientists have estimated that the threshold for runaway warming, the point beyond which the feedbacks become self-sustaining, lies somewhere between 2 and 3 degrees of warming above the pre-industrial baseline. We have already warmed by 1.2 degrees. We are adding to the atmosphere at a rate that, if unchecked, will see us reach 2 degrees within the next 15 to 20 years. Even if we implemented every proposed climate policy at maximum speed, we are on track for somewhere between 2.5 and 3 degrees by the end of this century. We are approaching the threshold in real time, and the institutional response remains one of careful study and incremental adjustment. We are rearranging the deck chairs. We are making policy adjustments that feel meaningful to those who make them, but that are utterly insufficient to the scale of the problem. We are talking about carbon pricing mechanisms and renewable energy transitions and efficiency improvements. All of these things are good. All of these things should happen. But none of them are addressing the fundamental question of whether we can change our collective behavior at a pace sufficient to avoid crossing a threshold that we cannot uncross. The PTM offers us a model of what happens when a civilization overshoots. The carbon entered the atmosphere. The temperatures rose. The system crossed the threshold. The feedbacks took over. The warming sustained itself for 200,000 years, independent of the initial cause. Whatever civilization or natural process produced that carbon signal did not persist to see the planet recover. They were not there when the system finally restabilized. They were erased from the record. All that remained was the chemical signature of what they had done. Is that the layer we want to write? Is that the message we want to leave for whoever comes after us? That we recognized the pattern, understood the implications, possessed the knowledge and the capability to change course, and chose not to. That we calculated the costs and benefits of action and decided that the immediate disruption was too high a price to pay for an uncertain future benefit. That we prioritized the comfort and profit of the present over the survival of future generations. These are not rhetorical questions. These are the questions that the geological record will ask about us 50 million years from now. And the answer we give to those questions is being written right now in every decision we make about energy, about consumption, about economic priorities, about whether we are willing to fundamentally restructure our civilization in response to knowledge about what happens when we do not. The layer is still being written, the fingerprint is still being set, and somewhere in the future, someone will find it and ask what we were thinking. What do you want it to say?